6 trigonometric ratios. Let's start with the three basic functions, sine, cosine, and tangent, with its abbreviation sin, cos, and tan. The other three functions are cosecant, secant, and cotangent, with its abbreviation CSC, sec, and cot. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. Now, to get its ratios, it is taken from a right triangle. Let us name this triangle as triangle ABC, and let us name the sides using the lowercase letters ABC. Now, since it is a right triangle, the longest side is called the hypotenuse. And let us use this angle. It is represented by a Greek letter named theta. So this angle theta here will serve as our reference. And this side B will be called adjacent side of angle theta. Then opposite to it is called the opposite side of this angle theta. Then the hypotenuse of this angle theta is always the longest side. Okay, so how are we going to get the ratios? This will serve as our guide. To find the sine theta, just take the opposite side divided by the hypotenuse and we have the ratio. So in here, since this is our reference, the angle theta, opposite to it is the side A, then the hypotenuse represented by C, therefore our ratio is A over C. To find the cosine theta, just take the adjacent side divided by the hypotenuse. So since this is our theta, the adjacent side is represented by B, hypotenuse is represented by C, so our ratio is B over C. And to find the tangent theta, so that is the opposite side over the adjacent side. So opposite to this theta is A, the adjacent is B, so our ratio is A over B. Now to get the ratios of the other functions, so since cosecant theta, secant theta, and cotangent theta are the reciprocal of these three functions, so the cosecant theta is C over A. That is the reciprocal of A over C. For secant theta, that is C over B. For cotangent theta, that is B over A. Now, let us apply this in our given, let's say, if we are asked to find the 6 trigonometric ratios of angle alpha in this triangle. So in this case, this will be our acute angle represented by this Greek letter alpha. But notice that in our given triangle, one of the sides is missing. But since it is a right triangle, we can use the Pythagorean Theorem to find the missing sides. So let us find the missing side, which is the hypotenuse. So the Pythagorean theorem is c squared is equal to a squared plus b squared, wherein c here represents the hypotenuse, then a and b represents the two legs. Let us substitute the value of the legs, which is 3 and 4, to a and b respectively. Then simplify. 3 squared is 9, 4 squared is 16, then add. 9 plus 16 is 25. Then to get c, square both sides so that c is left, then square root of 25 is 5. Therefore, our third side or hypotenuse is 5. And we are now ready to get the 6 trigonometric ratios of angle alpha. Let's start with sine alpha. So to get the sine, we will just take the opposite side over the hypotenuse. So the opposite of this angle alpha is 4 and the hypotenuse is 5. Therefore, our ratio is 4 over 5. To get the cosine alpha, cosine is adjacent over hypotenuse. So the adjacent side of alpha is 3. The hypotenuse is 5. So the ratio is 3 over 5. And to get the tangent alpha, so since to get the tangent, we'll just take the opposite over the adjacent. So the opposite of alpha is 4. Adjacent is 3. The ratio is 4 over 3. Then to get the other trigonometric ratios, CSC or cosecant alpha is the reciprocal of sine alpha. So the reciprocal of 4/5 is 5/4. Then the secant alpha, the reciprocal of 3/5, which is 5/3. And for cotangent alpha, That is the reciprocal of 4/3, which is 3/4.